Hello everyone. In today's video we're going to take a look at another example of implicit differentiation. The example I'm going to look at, I haven't solved it myself yet, straight from a book. 16y squared plus 9x squared y take away 54x equal to 0. Just going to solve this live. So part A of the book says find dy dx in terms of x and y. Okay, I'm just going to abbreviate that to find dy dx. Part C says find the coordinates of the point C where dy dx is 0. I'm just going to say when is dy dx 0. Okay, so let's take a look at the solution. So before we get started, we should notice the equation that we have is, well, it's implicit, which means that all the x's and the y's are mixed up. Instead of having something quite nice where we have y is a function of x, we don't have that. It's all mixed up together, and we should know the approach for finding dy dx in this situation, which is to just differentiate both sides with respect to x. And we need to remember that y just contains lots of x inside it. Okay, so the first term, 16y to the power 3. So the trick to these ones is just differentiate like normal. So the 3 comes down, drop the power by 1. And because there's a y instead of an x, we need to tag on a dy dx. Don't forget the 16 at the front. For the second term, this is where it's a little bit easier to make a mistake. This y here contains lots of x's. We don't know what's inside it. And we're timesing by x squared. And we need to differentiate this product. Well, we're going to need to use the product rule. So the product rule says take your two factors. So let's take 9 and 9x squared as one and y as the other. Differentiate the first, keep the second the same. Keep the first the same, differentiate the second. Okay, the third term, very simple to differentiate. It's just an x there with the number in front, minus 54. And the right hand side is also very simple. Differentiate 0, you get 0. Okay, so we're about halfway there in terms of finding dy dx. We've done the differentiation bit. We now have some algebra to deal with. We want to collect together all the dy dx terms. So just circle those. I find the simplest way to do this is to write dy dx and then open up a bracket and find how many we have in total. So we have 16 times 3y squared in the first term, so 30 plus 18, 40, 48 y squared. The third, so that's the first term done. The third term, 9x squared. That's that done. What's left over? Just move that away from the dy dx. We have this and this. Okay, now to get dy dx on its own, we just simply move everything else to the other side. So let's begin by moving these over. So we have dy dx times this bracket. So I'm going to add 54 to both sides, take off 18xy. And finally, divide both sides of the equation by 48y squared plus 9x squared. So we get dy dx is 54 take away 18xy, all divided by 48y squared plus 9x squared. So it was a little bit algebra heavy, but not too bad, I feel. maybe it's easy for me to say. The more of these questions you do, the easier it gets. Dy dx is this fraction. Okay, so that's part A. Most important thing here is not the answer, it's the process, things to remember. You see something that's implicit, just differentiate outright from the beginning, and then get involved in the algebra and isolate that dy dx. Okay, part B, some of the higher marks. When is dy dx equal to 0? Well, we have a fraction for dy dx, so the question is, when is this fraction 0? And we know this fraction here is 0 when the top is 0. Okay, so let's go to a clean page. We have the following. Dy dx is 0 when the top is 0, so 54, take away 18, xy is 0. Let's rearrange this. So we have x times y is 54 divided by 18. Should we simplify that a little bit more? So we have a 9 and a 27, which is a 3. Okay, so x times y must be equal to 3. Okay, so that's great. We have a condition, a relationship between the variables x and y for when dy dx is 0. But unfortunately, we don't have these explicitly. We don't know what the values are yet. So we need some idea to figure out how to get them. So this is true when dy dx is 0. We also know for any values of x and y, well, they satisfy the original equation, the implicit equation for any x's and y's. So what we have is two equations, two unknowns, and hopefully we're able to solve. Okay, so we need to make some substitution. So we need to decide which variable to eliminate, and then we're going to substitute one of the equations into the other. So I think I'm going to eliminate the x's. I've just got a feeling that's going to be a bit easier. So let's do x is the same as 3 divided by y. And I'm going to put this in. So I get 16 y cubed. I didn't want to touch that y cubed. 9x squared times y. Take away 54x equals 0. Okay, so this says that 16y cubed, so we have 9 times 3 squared, 81. We have a y squared on the bottom times y, and they're just going to cancel, giving 81 over y. This next term is 162 divided by y equals 0. Okay, so these two can be collected together. So we have 16y cubed is minus 81 over y, times in through by y, and then actually I'm going to take the second term over first, and then multiply by y. I find that 16y to the 4 is 81, so y to the 4 is 81 over 16. At this point I start to feel quite confident because these are both powers of 4, so I feel like I've done something right here. So this implies that y, so we take the fourth roots, so fourth root is going to be 3 divided by 2. And because there's an even power, we could use a negative, and that would result in a final answer of a positive number. So there you go, we found the values of y. Now it's a case of finding the values of x. Well, I can just use this equation. So let's do it. So if y equals 3 over 2, x is 3 divided by 3 over 2, which is 2. And, oops, that was a terrible and. And if y is minus 3 over 2, then x is minus 2. So there you go, the final answer. We have x is 2, y is 3 over 2, x is minus 2, y is minus 3 over 2. There you go, that one. Too bad, did that one live as well. Hope you find it useful.